Morning, everyone. Welcome to this session number 353. And today I will participate in the contest, in the Biweekly contest number 142. And I hope that get better result than my previous contest. But well, I hope that get a better ranking. Okay, we this what? Oh, what is happening? Uh, 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 Okay, fine. Okay, find the original type string 1. Alice is attempting to type a specific string on her computer. However, she tends to be. What is this? Clumsy. Okay. And may press a key for too long, resulting in a character being typed multiple times. Although Alice tries to focus on her typing, she is aware that she may still have done this at most once. You are given a string word which represents the final output displayed on Alice's screen. Return the total number of possible strings that Alice may have intended to type. Okay. This case is A B C C C C A B C C C A B C C A B. What? Okay, okay. This is the original. Maybe. Now this is another. This another. This another, and this is another. Okay, for this I think that is only replace every letter. For example, in this case, it is one. Now another is removing one duplicate. Now the next is removing another duplicate. Yeah, in this case is this. In this case, come on. What is that? Okay. Another is remove, for example, this. Another is, what is happening with this? I'm not sure if I turn on one special thing in my keyboard or is leetcode. But what? Okay, now the another is this because remove the first, and basically the number of elements is for every letter it's a new possible. In this case is what is this, how many elements I have in this how many duplicates I have this here. In this case we have 1 2 3 and 4, means that, okay, I need to return the a number. Okay, in this case is 1 duplicate, 2 3 and 4 should be returned 4 plus the original is 5. And now in this case is this, in this case is 4. Yeah, I think it's this. Sorry, it's so noisy here. This is so Mexican. The real Mexican song. Okay, in this case is integer size, it's equal word dot length, yeah, as before, that count the duplicates. Oh, for handle the duplicates, I can use the array letters. It's equal new int of the size 26, and here is integer. No, char C word letters in the index C less A plus plus. And now basically is only count or transversal this array the letters dot length I plus plus, and here I need the counter integer size. The original size is 1, and only is increased here if letters in the index I are greater than 1 is size plus equal letters less 1. Why less 1? Because this is part of the original, yeah, and I think that it's only that. What? Okay, 5 1 8. I think that it's done. Oh, what I put? Why appear to? For this. It's because the original is this. Now the next that is the E, that is 2 plus less 1. Why spec 1? Let me check here. But with the original, okay, let me check. We have this, but another option is this. It's 2. Why is Why is 1? Okay, let me check again the description. Return the total number of possible original strings that Alice may have intent to type. Okay. It's because this appear twice, but it's not caused for this long press. Are divided. or I think that is transversal the letter, and when it repeat, for example, this is one, okay, don't happen nothing. Now this is B, B, if appear another B, for example, here appear the C, okay, we have the double B, I repeat, we need add, basically it's here. If the previous, but for this I need to change this for integer I is equal 0, and while I is minus 2, word dot length I plus plus, and here is less 1. Yeah, because we need compare it with the next, with the next, with the next, with the next. And where are separate, basically are ignored. When are different, are ignored. Here, if word in the index I it's equal to word in the index I plus 1, if both are equal, this is plus plus. Yeah, in this case, for example, this is equal this, no, okay, this is equal this, yeah, B have 1, this is equal this, no, but in this case where it's not, I need increase in 1 this. No, but in this case do the same, plus equal to, for example, this is equal this, no, okay, A have 1, this is equal this, yeah, increasing 2, this are equal this, no, okay, means that B increasing 1, no. Okay, another option is intake char C it's equal word dot char at in the index 0, and here is the current, well, yeah, the current it's equal to the previous, it's equal to the current. I think that this, if both are equal letters is plus plus. In the case that are different, P it's equal C. Okay, I start here in 0, and if we are transversal, I need to transversal this. I start with the A it's equal A, okay, plus plus. Now the next is the letter B it's equal A, no, okay, now the previous is B and the letters plus plus. Now the next that is B it's equal B, yeah, but in this case do the same in both cases, don't make sense this. I think that only should be increased where the previous value is the same. If the previous value is the same, is increased. And other case, b is equal c. Word dot char add in the index I. Let me check it here. Come on. Word in the char add in the index I it's equal p. What? Letters. We create this, and this is basically c. It's equal. Other case is this. One. Oh, come on. Why I pick 3? 1. Here I pick 3. I need to handle the case where one. Okay, for example, here is when all of yeah, when all the values have 1, yeah, have 1 or 0, integer extra it's equal 0. If letters in the position this, even is here. If extra boolean extra false, if happen this means that exists at least one duplicate, means that this is true. Maybe it's better in the positive way. And now here is plus, and here is true if extra size plus plus. Okay, I think that is we have more one duplicate. I am increasing the elements that appear on the one. My gosh, I spent many time in this problem. In this case, we start here. The letter A is equal to the B. No, okay. Letter A is still in 0. Now B. This B is equal to this. Yeah, are equal. Means that increase. Now this is equal to this. No, means that P now have the value of C. C is equal to the previous, yeah, increase. C is equal to the previous, yeah. C is equal to the previous, yeah. Here will contain at least one duplicate. Four, 1, 4. Here is 4 or 3? And 1. What? These cases. Is the first? Why? Sure. Oh no, I forgot. Ah no. Okay. At least I don't lose my. Why is returning 4, 1, 4? Okay, the first I am transversal this. I need the way to discover the groups of words, you know. And for example, for here, oh, I think that I can take this. The next is duplicate and no. Okay, can ignore. Now this and this are equal. Yeah, we have 2. 2 divided between 2, it's equal. No, 2 less 1, it's equal. It's equal 1. Yeah, currently we have 1. Now these are equal. No, this and this are equal. Yeah, basically it's another 2 less 1, it's equal 1. Yeah, this and this are equal. Yeah, it's again 2 less 1, it's equal 1. And this and this are equal. Yeah, 2 less 1, it's equal 1. We have 4 and the complete word is 5. Okay, let me check with this. This with this are equal. No, this and this are equal. No, this and this are equal. No, this and this are equal. We have a pair. 1, 2, 3, and the complete 4. In this case we don't have any 1, and here is equal and this equal. No, this and this are equal. No, basically we have only 1. Yeah, I think that it's only this. I don't need do anything of this. It's only count the pairs and that's it. Even I don't need this. I need here the counter starting 1, and here is basically the this the current and the previous, current and next, and this start in 0 and stop 1 before. If C it's equal n, basically counter plus plus. Yeah, and now yeah, I think that it's only that. 5, 1, 4, 1, or I hope. Okay, well, I was complicated a lot the problem. Find sub tree size after change. Okay, one moment. I am checking. I am online. Ah, yeah. Okay, sorry. This is the problem. Find sub trees size after change. You are given a tree rotate node 0 that consists of n nodes. From 0 to n less 1. The T is represented as an array parent of the size n, where the parent in the index I is the parent of the node I. Since node 0 is a root, parent 0 is equal less 1. Okay, got it. You also are given a string of the length n, where s is the character sent to node I. We make the following change on the tree one time simultaneously for all nodes x from n. Find the closest node at y such that x. Find the close node y to node x such that y is an ancestor of x. If y doesn't exist, do nothing. Otherwise, remove the edge between x and its current parent and make node a new parent. What is the other problem? This sounds like as a graph. Okay. Yeah. Return an array answer of the size n, where answer in the index size is the size of the subtree. Rotate at node I in the final tree. A subtree of the tree names is the tree consists of node tree name. For example, in this case, this is the parent of the first element, that is 0. The parent is 1, 2, 3. And it's not a binary tree, it's only a tree. The parent of, no, the 0, 1, 2, the 3, 4, and 5, the parent are 1. And this, every letter represents this. The parent of the node 3 will change. The parent of node 3 will change from node 1 . Six, 1, 2, 3, 4, 5, 6. Now the next is 1, is 3, 3. The next is 1, 0, 1, 2. The next is 0, 1, 2, 3 is 1, 4 is 1. But I don't understand. Find the closest node y to node x such that. Sorry, this is a problem. But I still don't understand. In this case, the first is find the closest node y to node x such that y is an ancestor of x. I don't understand. I don't catch this. Find the closest node y, but what is y? You make the following change from x. I think that y is left and x is right. Find the closest node y to node x such that y is an ancestor of x and x, the value I think it's equal I don't understand this. Okay, I can assume this is related with this value and this is the same. But in this case, for example, y is 6. We make the following change on the tree one time simultaneously for all the nodes. In the operation, basically apply all the change over all the elements. Find the closest node y to x. In this case, 0 with 1. 0 with 1. And that's ancestor. I don't understand this question. When the one comment or something, because I am completely loose with this. Let me check. And the answer is subtree name. Let's see. Where answer is the size of the subtree rotate and the node, yeah, in this case is 6. Or for the parent, for the 0 is less 1. Okay. Okay, I think that I am understanding. Let me check. Here. And this is the result. Yeah, and basically okay. Now here basically is that we start here. Need to increase this. Okay, I think that it's enough with this. Now okay, we have 0, 1, 2, 3, 4, 5. And the first point is that the first consideration here is that we make the following change on the tree one time simultaneously for all the nodes. Basically, for example, +1 is +1 for all of them, all. Yeah, this is a meaning of this line. Find the closest node y to node x such that y is an ancestor of x and the value are the same. For example, the original values for this is that the zero, the ancestor is less 1. Now for the 1 and 2, they are children of now 3 and 4 are children of this, and now the 5 this. Okay, now say this said that find the closest node y to the node x. In this case, for example, the node is 0. Search this is y. The closest x. Okay, this is the parent of this, yeah, basically this element, yeah, because less 1 or this is parent of this and this, but the most close is this. If x doesn't exist, no, but in this case exists. Other ways: remove the h. What is h? H is the connection, right? I always get confused with the is the connection. Now here is remove the connection between x and its current parent, and make basically we have 0 and 1, and said that remove this connection with less 1. Yeah, this is remove it, and now the parent of the and not y, the new parent of x. Yeah, basically this is move. Remove the h between okay, let me come back. Is remove the h between this. Okay, remove the h between x and its current parent. No, it's with this less 1. And make not y the new parent of x. Like this. And adding an h between them. Yeah, basically this. I'm sorry. And continue with the others, because say that we make following change on the tree one time simultaneously, only one time for all the nodes. In this case, we start with the 0. Now the next that is the 1, and okay. Now we are here. Now the next that is the one. In this case, the one is search the next X element that is the tree. This now basically this tree, this cut the connection with the parent, and now this tree, is a child of this, and now this with the next it's all, and basically we start. Okay, the first is for the index. I don't understand the question. Yeah, it's a little hard. And another point is that I'm not sure if I need to simulate the tree, because in this case is okay, the first element is 0, is 0, 1 2 3 4. In which moment appear this letter? Yeah, no, it's 0 1 2 3 4 5, and the letter is A B C. Now the next that is start with this, that is the letter A. Now we are saying the next elements 1 and 2 are child of this, 1 and 2, that one is B A. Now the next that is the 3 and 4 are child of the 1, 3 and 4, and 3 is A and 4 is B, and the last is 5, that is the same. Here is 5 and is C. Now the next, okay, do you imagine that we have this 3? Now the next that is find the closest node Y to node X such that Y is ancestor of X. If we start here, we know that this is ancestor, that this is Y is ancestor of these elements. But we need search the child of this tree that contains the letter A. In this case, the more close is this. Yeah, this child, because contain the same letter. In this case, otherwise remove the H between X and its current parent is this, because this is X. This is X and this is Y. Okay, now it's good the connection between this and this. And its current parent make a node of Y. Okay, basically this automatically is transformed as a child of this. Okay, here. And what else? Here we made the following change on the tree simultaneously for all the nodes. Okay, I think that we start with the 0. Now, where is the 1? Here. This is the 1. Now is this. This is X. And we need search another B that is this. Now this connection is good. And this and this now is parent of this. And now is the 2. Where is the 2? Is here, right? This is the 2. Now this this is Y and should be another one child that is have 1 is this. Okay, this connection is good, and basically this is convert as a this is convert as a parent of this. This disappear. And now we are in the number is the 3. We search in the 3 that is this, don't have anything because it's a leaf. Now the next that is the 4. What is the 4 here? B and B. Okay, basically this change. Oh no, this change as a child of this. This is good and disappear. And the last is the 5. Where is the 5? Don't do anything. And basically, return at the same position. And for this reason, the 0 contains 6 elements because it's basically all of them. The 1 contains 4 elements, no 3. But why this contain 1, 2, 3, 4, 5? 1, 2, 3, 4, 5. Why is 6? The first I have to make the y is 6. This is makes sense because basically is this. Now the next that is 0, 1, 2, 3, 4, 5. And if I following this is the 6. The 0 contains 1, 2, 3, 4, 5, and itself 6. Okay, got it. Now the next one is 1, 2, 3, and the itself is 4. Now the 2 is this, itself is 1. Now I have done y here is 3, but well. Now the next that is 3 is 1, 4 is 1, and 5 is 1. I have this though. Y, the parent of node 3 will change from the node 1 to 0. The parent of the node 3 will change from node 1 to 0. I'm not sure if I am understanding this problem because the first is that I don't know why it's 3 and not 4. Yeah, and this case is less 1 is A. I'm so sorry. The first is 0 and the parent is less 1 and is A. And the parent is less 1. Now the next that is the index 1 have the value no. The index 1 is child of the 0. The index 2 is child of the 4. Here. The 3 is child of the 2. No, the 3 is child of the 0. And the 1 the 1 no 0 1 2 3 and 4. The 4 is child of the 1. And now we have this A. Okay, the first is that start with the first, that is the 0, and search the child that contain the same letter, that is this, is change 0 for 4, and now this is convert as a part of this parent of this. The parent 4 will change from the parent to the node 1 to node 0. And now with the 1 is the letter B. Should be search the near letter B, that is this, is 1 change with 2. Now the next that is the C, that is B, is no, yeah, but in this case I have my doubt. Why this is 3 and not 4? Maybe I do one thing wrong. Okay, 0 1 2 3 4 5. The first is built at the 3. In this case the first element is this, and the 0, the parent is this 1, that is the root. Okay, this is the root. It's important to mention that it's not in order. In this case appear, but it's not in order. Now the next that is the 1 and 2 are child of this 1 and 2. Now the 3 and 4 are child of this 3 and 4, and even the 5. Yeah, okay, now got it. Now basically this is A, B, A, B, C. Okay, like this. Now the next that is basically start with the 0. Yeah, that in this case is the parent, and next to is search the near I think that applying a BFS, I think, over these elements, because can have multiple. It's not a binary tree. Yeah, I think that is search. Okay, what is the next letter A? The next letter A is here. Yeah, this have the same value, and this is parent of this. For this reason we start with the root. Yeah, in this case is this. Okay, now this will be a parent of this. This is good, and now this is moved as a parent of this. Even, you know what, I will remove of this. Okay, got it. Now the 0 is done. Now is the 1. Where is the 1? The 1 is here. the letter B, it changed to this. Now here is 4, connect with 1, and this disappear. Yeah, and this is B. Now the 2, what is the 2? Is here. The child is this. Now this is parent of this, that is 0, is parent of this, and this disappear. Ah, come on. And now it's letter A and A. Now the node 3, what is the 3? Is this, not happen nothing. The 4, what is the 4? Is here, the next is this, okay. This is converted automatically as a child, and this is appear, and the last is the 5. No, the 5. The 5, what is here, that's it. Okay, now if we do again this, sorry, I have disconnection. For the latest index, for the 0, we have 1, 2, 3, 4, 5, and the tail is 6. Now for the index 1 is 1, 2, 3, and 4. Still appear the 4. Why the answer have 3? Why appear the 3? Yeah, in this case, start in this, and after apply this operation, is the same. Why is 3? I think that I did the right test. Why is 3? Or maybe the parent always start with, is they only have this value, and the others, okay, let me check, maybe it's this, only the parent have this conditional that increase +1. Okay, only that. The first is with this is enough. Now the next that is 0, 1, 2, 3, and 4. We know that the first is 0. Now the next that is the 1 is a child of this. Now we have this, that the 4 is child of 2, that the 2 we don't know where, it's 2. Now the next that is 0 is child of 3. Okay. And now the next is the 1 is child of the 4. No. No. Oh no, yeah. These are the parent, and this is the nodes. Okay, now in this case, the parent of the node 0 is less 1. Okay, and the letter is A. Now the next step is the parent of 0 is 1. No, the parent of 1 is 0. The parent of 1 is 0. The parent of 1 is the 0. The parent of 2 is 4. The parent of 3 is 0. The parent of 4 is 1. Okay, and the 1 appear here. Okay, and now is 0, 1, 2, 3, and 4. Ah, I forget the. Okay, this is. Let me check if it's the same. Both. Now, 0. B is 1. B. B. AB. Okay, and now is starting with 0. The 0 in this case is this, and is search the next or the closest letter A, that is this. Now this, I think that I can code this. And come on, like this. Now is the turn of the 1. The 1 is the letter B. And I search the near or the closest letter B, that is this. Okay, now this got the connection and is moved to this. We have the 1. Now the 2 is, what is the 2? Here, B and B. Okay, basically change this by this. Now the 3 is this, don't have the nothing. The 4, that is this, A and A. Means that this is good here. And now this is a child of this. And the last, what is the last in this case? I'm not sure it's 4. Yeah, it's 4 because the 5 doesn't exist. Okay, and now we need to calculate the size for the index 0 is 1. In this case is the root, means that is plus 1. Okay, we start with, this is 1. Oh, well, in other words, sorry, is count itself. But in this case, 1, 2, 3, 4 plus 1 is 5. 1, 2, 3, 1, 2, 3, 4 plus 1 is 5. Okay, now for the index 1 is 1. No, it's 2. Or 1. I'm not sure because where is alone is basically itself. 1. For the 2 is 1 or 0. For the 3 is 0, and for the 4 is 2. 5 2 1 1 5 2 1 1 1. Why? Mm. 3 and 4, and the final we have this. Okay, return the size. For example, for the size for the 0, that is the root, basically is all of them. 1 2 3 4 5. 1 2 3 4 5. Now for the node 1 is this 2. Now for the node 3 is 1. Now for the node 4 is 1. No, is 1 2 3. You know what? I will start at least building the tree node. I'm not sure why this. Maybe I am doing wrong the simulation. But well, the first point is that we need to here. We need to build this this tree. And the way to do it is create a hash map and put the index 0. No. The first is less 1 is the index 0. Now the 0 is this. Now the next that is 0. The index is this. Now the next that is for the 1 is the index 3, 4, and 5. Okay, and now the next that the next is start with the index 0. Where is the index 0? The index 0 is this. And we are saying that we have y in 1. This is wrong. This is 2. Sorry. The most near child, in this case, is 1. Okay, now this change the position. Okay, this disappear of this, and this is at here, and only that. Now the next that is the 1. Why appear 2 ones? No, this is less 1, sorry. Now for the 1 is, what is the 1? Here, the more near is the 3. Okay, means that I need the 3 that doesn't exist, have the 1, and this disappear. Now the next that is the 2. Yeah, in this case the 2 appear here. No, then what is the 2? If I save in the positive way, first the value next to the parent. In this case is the value is here 0 less 1 1 0 2 0 3 1 1 5 1. Yeah, and now the next step is, okay, we are mapping this, whatever. We start with the 0 and is search. Okay, what is the parent of the 0 is this. We need search the element. No, it's in the positive way, because we need save the values. And you know what, I can, if I know that the size in this case is 1 2 5 6, 1 2 3 4 5 6, I think that is 6 less 1 is equal 5. I can create here, yeah, yeah, in this case the parent of less 1 is the 0. Okay, the parent here is the parent child. The next is the parent 0, contains the 1 and the 2. Now the parent 1, and here for example should be appear 1 0 1 2 3 4 5. Yeah, now the next is the parent of 1, contains the 3 4 and 5. 3 4 and 5, even if this is sorry, this is empty, it doesn't matter, but we can use it. Now the next step is and obviously we need mapping these values. I'm not sure if the values are it's possible to repeat the values. I think no, because it's an increased order, right? It's 0 1 2 3 4 5 whatever, means that I can, what is the max size of the disk? The parent n, and n is, oh no, the letter, yeah, the letter can repeat, and the maximum value is this. Basically I need to mapping the position 0 is with, oh no, here is mapping, yeah, basically these are the value in this array. Got it. Now the next step is performance this operation. That is, okay, we start with the 0, this is the parent, we start with the 0, and now the childs are 1 and 2. Okay, means that I need change. The 0 will be converted as a child of 0, and this disappear of this. Yeah, basically is remove child and add parent in the child list. Yeah, I had one here. He's remove the child and add the parent to this. Okay, now this is the 0. Now the 1, what is the 1? Here. The close is this. Now means that this disappear, and I add the 1 here. Now the 2 is here. The childs don't have anyone. Now the 3 is here. Have the 1, means that I remove the 1 and I add the 3 here. Now is the 4. The 4 is this, is empty, and now is the 5, that is this, is empty. And now is search how many childs I have. For example, we start here 1, let me check. Maybe I did the incorrect performance. Okay, less 1 is 0. In the 1 it's 1, 2, 3, 4 and 5. Okay, and we start in the index 0, that is this disappear, and we add the 0 here. Now the next step is the 2. The 2 don't have anything. Yeah, that is this. Now the next step is the 3. No, don't happen nothing. No. We have with the 0. Okay. Now is with the 1. Now the 1 is the 3. Yeah, means that I need to remove this and add the 3 here. That's it. Now is the 4. No, is the 2. The 2 don't have nothing. Now the next step is the 3. The 3, sorry, this is 1. Have this means that I need put this and remove this. Now the next step is the 4 and the 5. And we start here is 1. And you know what? I forget completely the letters again. Yeah, for that reason I think this doesn't work. Now we start here. Okay, got it. And the less 1 is the 0. The 0 is the parent of 1 and 2, and for the 1 is 3, 4 and 5. 3, 4 and 5. And now we start with the 0. In the 0 we have 1 and 2. The 1 and 2 is basically B and A, and the 0 is A. What is the element that contains the same letter? That in this case is the second, that is 2. Okay, I put here the 1, and this disappear of this 1. 0. Okay, let me put here 0. Okay, and that's it. Now the next dot is the 1. Now 1 is here, and it's 3, 4, and 5. 1 have the value of B, and the other is ABC. ABC. Okay, the first letter that is similar to this is the 4, means that I need to move the 1 in the 4, and the 4 disappear of this 1. Okay, got it. Now is the 2. Okay, the 2 contain the 0. The 2 in this case 0, 1, 2 is A, and the 0 is A, means that it's only swipe. Here appear the 0, and this disappear of this. Now the next dot is the 3. My gosh, the 3 don't have nothing. The 4 have the 1. Okay, it's 4 and 1. The 4 contains the letter B, and the 1 contains the letter A. Don't do anything. And now is the 5. 5 don't contain anything. Okay, now is calculate the size of these elements. For the 0 basically contains the 1, 2, 3, 4. Then I'm not sure if I need to count the starting with the less 1 go to the 0, the 0 go to the 1 go to the 3, the 3 go to the nothing. Now is go to the 5, don't do anything, come back to this, and 0, 1, 2, 3, 4, 5, 6. Okay, now how many time I have? 10, 10 minutes. Now here is the next is 0. The 0 contains the 0, go to the 1, go to the 3, go to the 5, go to the 5, nothing. Change these 2, and that's it. 1, 2, 3, 4, 5. Why? Okay, again. I think that I have the right approach, but in this case, okay, 6. Now the next that is the 0. The 0 contains the 1, 1, 2. The 1 contains the 3 and the 5. The 3 contains nothing, the 5 contains nothing. Now the 2 contains nothing. Now the size is 4. In this case appear 4, but well. Do you imagine that I remove 1? Okay, 3. Only for the root, count the root and root itself and the less 1. Now the next that is the 0, 1, the 2. The 2 is 1, it's empty. Now the 3 is empty. This is the 4. Now the 4 is 1 plus 1 is 2. Here I don't understand this. Why this? No, in this case it's wrong because we are saying that the parent of the 1 is 4. One and 2, 3 and 4, 5, 5, and in this case is starting find the close node y to x such that the y ancestor and the values are equal. Okay, if we start with the node 0, yeah, the first is 1 and 2. You know what? I will put here 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, and it's A, B, C. For the this that is A contains the 1 and 2, that 1 is B and 2 is A. Is connect with this, basically remove the H between X, remove the for example, I search this element here. I need to put the relation with this. For example, this disappear, and now the 2 is the parent of 0. And now is the 1, that the 1 is the letter B, and the 1 contains 3, 4, and 5, that is ABC. I only matters the letter, the 4, and we are saying the 1, remove the number 4, and the 4 is now the parent of 1. Now the 2, that is A, contain the 0, that is A. Yeah, in this case is the first or the most near. I need that move the 0 disappear this and appear here. Okay, we are in the 2. Now the tree that is represented by the A, the tree don't do anything. Now the 4, the 4 that is B should be searched, in this case in the A, in the 1 that is B. Oh, that is B, means that this disappear of this and the 4 appear here. And now the 5 don't do anything. Okay, now if we start with the first is the 0 go to the 1, 1 go to the 3, 3 is done. Now come back. 5 don't do anything, come back to this 2, and 4 is 1, 2, 3, 4, 5, 6. Okay, the 3, I hope that appear the 3, please. Now the next that is the 1. The 1 go to the 3, the 3 don't do anything, go to the 5, don't do anything, and it's a 3. Okay, now the next that is the 2, the 2 don't do anything, the 3 don't do anything, the 4 don't do anything, and the 5 don't do anything. Okay, finally. Okay, how many time I have? Oh no. I discovered the solution late, but well, it's a hash map, integer, list of integer, map is equal new hash map, and here is for integer node it's equal 0. Meanwhile node it's minor that parent dot length I++, and here is map if the parent doesn't exist. Parent, no, here is node, I think. If map.contains node, create, in this case is node new array list. Yeah, it's only for create. Now here is the same with the real parent. Here is parent. If the parent doesn't exist in the index node, if doesn't exist, add the parent. Yeah. And now the next that is map.put, no, map get the parent dot add the index I, no, the node. Now here is, okay, we are filled. Now the next that is, oh, but for the first is less 1. I'm not sure if it's important this. Well, I have the map. Now the next, what is the next? The next is, we have the position of this. Now we have this. We start with the 0. 4. Integer I it's equal node it's equal 0. Meanwhile node it's minor that parent dot length. No, I have 1 minute. Now here is DFS that receive the node, and means that I will transform this as a public here the DFS receive the node, and I need search the now here, and I need the private void DFS. Yeah, it is DFS receive a node that in this moment is the node that in this moment is the parent. The first time is the parent, and then I tried, but again I only resolved I solved only one. Well, I think that I had the idea. In the next transmission I will continue with this problem, but I think that I had the right approach for the find the subtree size of the change, and I can bet that this is similar with the graphs. And what is this? It's like this the first, but in this case it's hard. But well, thanks for following this transmission, and I hope I see you in the next. Bye bye.